welcome to the Deep Dive. Today we're taking a bit of a shortcut to being truly well-informed, zeroing in on, well, a real cornerstone of artificial intelligence in the professional world. You've asked us to unpack a very specific, yet incredibly vital section of the AAIA Advance in AI Audit Official Review Manual, that's Chapter 3, Part D. Think of us as your expert guides, kind of navigating the nuanced landscape of AI audit techniques. Almost like instructors walking you through a complex but really crucial topic.
Precisely. Our mission today is to thoroughly explain Chapter 3, Part D. It focuses squarely on data quality and data analytics. And this isn't just about, understanding the superficial elements of data. It's about grasping why it's the absolute bedrock for reliable, ethical, and effective AI systems, and crucially for conducting meaningful AI audits. We'll go through it topic by topic exactly in the sequence laid out in the manual. We want to make sure you grasp every important nugget of knowledge and its profound implications.
Okay, sounds good. Let's unpack this crucial part of AI auditing, starting right at the very foundation, data quality. #I. Data quality, section 3.13. Data quality. It sounds so straightforward, doesn't it? Almost mundane. We've talked about data quality for decades in IT. But in the context of AI, it seems to carry this immense, almost existential weight. What exactly elevates data to quality data for AI, and why is this concept, maybe now more than ever, so incredibly important?
That's a really perceptive observation. What's truly fascinating here, and something the manual emphasizes very clearly, is that for AI, data quality isn't merely like a desirable trait. It is critical, absolutely critical for AI models to produce reliable insights, make sound decisions, and, perform optimally. Without it, you're not just building on shaky ground, you're building a potentially massive, complex structure on quicksand.
Quicksand, wow, that's a strong image.
Well, think about it. An AI system, whether it's some sophisticated deep learning model or a simpler predictive algorithm, it's fundamentally only as good as the data it learns from and operates on, right? So if that data is flawed, incomplete, inaccurate, or biased, then any conclusions drawn by the AI, any decisions it makes, will inherently carry those flaws forward. It doesn't matter how elegant or cutting edge the algorithm itself is.
Right, the algorithm can't fix bad ingredients.
Exactly. And the scale and interconnectedness of modern AI systems mean that even, small data quality issues can magnify rapidly. They can lead to systemic failures, not just isolated errors, potentially impacting millions of users or billions in revenue. The manual provides a concise yet powerful definition. Data quality is the degree of excellence in data, specifically enabling accurate reporting, and by extension, accurate AI model training and inference. This means data that isn't just there, but is consistently trustworthy, clean, and fit for its intended purpose. It's about ensuring the raw material you're feeding into your AI system is pristine, correct, and truly represents what it's supposed to.
Okay. Pristine and trustworthy.
Without this foundational excellence, any AI built upon it will struggle. It'll struggle to deliver dependable, fair, or even legally compliant results. It's the classic garbage in, garbage out scenario, just amplified exponentially by AI's capabilities.
So it's definitely not just about having lots of data, the whole big data thing. It's about having good data. And the source highlights this critical interrelationship between data quality, data integrity, and data profiling. I'm picturing, like you said, a visual. Can you elaborate on how these three concepts intertwine? Maybe you reference that diagram you mentioned, and why understanding their interplay is so vital for AI audit.
Absolutely. The manual uses a really powerful visual. It's a Venn diagram, figure 3.10, to illustrate this precisely. It shows how these three critical areas overlap and contribute to a larger holistic goal: effective data management. It's not about three separate silos, you see. It's three interconnected pillars supporting reliable AI.
Okay, break it down for us. What's in each circle?
All right. First, data quality itself. This covers a range of characteristics that define its fitness for use. Things like accuracy. Is the data factually correct? Precise. Think medical AI and inaccurate patient record. Could be catastrophic.
Life-threatening, yeah.
Correctness. Similar, but often about adherence to standards. Is New York always spelled the same, or do you get NY? NY, and AI needs that consistency. Consistency. Does the data contradict itself across different systems or times? Customer address different in sales versus shipping? Logistics, AI will struggle.
Makes sense.
Completeness. Are there missing values where you expect them? Training an AI on financial data with missing transaction amounts, unreliable forecasts. Imagine a credit scoring AI fed records missing key financial details, its risk assessments. Fundamentally flawed.
That's a big one, missing data.
Huge. Then timeliness. Is the data up to date? Relevant. For stock market AI, minutes-old data might be useless. Consumer trends AI needs the latest purchase data. Validity. Does it conform to rules, types, domains? Is a number field always a number? Is age reasonable, not, say, 200? And finally, relevance. Is the data actually pertinent? Sometimes you collect tons of data, but only a fraction helps the specific AI task. Irrelevant data adds noise.
Okay, that's a lot under the data quality umbrella. What about data integrity? How's that different?
Good question. There's significant overlap, definitely, but data integrity often relates more to the structural soundness. It's adherence to established business rules. It's about maintaining accuracy and consistency over the entire life cycle, preventing corruption, basically. Think of it as the guardrails for your data.
Guardrails, I like that.
It includes things like entity integrity, ensuring unique identifiers, like a primary key, so the AI can distinguish individual customers or products accurately. Referential integrity, maintaining relationships between tables, making sure every order actually relates to an existing customer, for example. And domain integrity, ensuring values are within acceptable ranges or types, like age being a positive integer. If an AI processes sensor data, domain integrity checks ensure readings are within expected parameters, preventing errors from skewing, say, anomaly detection.
Okay, so integrity is more about structure and rules over time.
Exactly. And if an AI uses transactional data with integrity issues, partially recorded transactions, wrong categories, its financial analysis could be way off. An auditor would look for robust data validation rules, access controls, things that maintain this integrity.
Got it. And the third circle was data profiling.
Right, data profiling. This is fundamentally about understanding your data, analyzing what you have before you build. It involves digging into its structure, content, relationships, understanding the metadata, data about data, what is it, where's it from, its format. Profiling helps identify duplicates, inconsistencies, patterns before they mess up your AI.
Like finding a customer ID field isn't unique.
Precisely. Or finding negative values in a revenue column where there shouldn't be any. This detailed understanding flags potential issues impacting quality and integrity. It's invaluable for data scientists and for auditors, too. An auditor can quickly grasp the data landscape, feeding an AI, and spot immediate red flags.
So quality, integrity, profiling, they all overlap.
Yes, and their intersection, as Figure 3.10 clearly shows, leads to what the manual calls effective data management. This isn't just jargon, it means a holistic, proactive approach. Data isn't just collected, it's carefully governed and managed throughout its life cycle, from creation to archiving, ensuring it's consistently reliable for AI. It's active stewardship, not a one-off fix.
So circling back to the audit perspective,
Yeah.
what does this all mean specifically for an AI audit? Why is this so fundamental? It feels like the absolute bedrock.
It absolutely is. And this raises that important question for any organization using AI. If the data is poor, fundamentally flawed, mismanaged, it doesn't matter how sophisticated the AI model is or how rigorous the audit technique applied to the model, the results will be compromised. Auditors need to ensure that the data used to train, test, and operate AI systems meets high standards of quality and integrity.
Establishing trust in the inputs first.
Exactly, to ensure trust in the outputs. An AI audit isn't just checking the black box, it's meticulously examining the ingredients. What went into building the box, what's continuously fed into it, how those ingredients are handled. If the underlying data is biased, incomplete, inaccurate, the AI will produce biased, incomplete, or inaccurate results.
Which can have huge consequences.
Huge. Business, ethical, regulatory consequences, discriminatory lending, inaccurate medical diagnoses, flawed financial predictions. The auditor's role is to verify these foundational data elements are sound, reliable, managed effectively. Because without that, auditing the model's logic is almost, well, moot.
So they use things like data sampling.
Yeah.
Analyzing lineage.
Precisely. Sampling to verify accuracy, analyzing data lineage for consistency, scrutinizing data governance policies, all to confirm that foundation is solid. Hashtag tag 2, data optimization, section 3.13.1.
Okay, building on that absolutely critical foundation of data quality, the manual then moves us to data optimization. It's something, maybe a bit provocatively for some, that AI success hinges on optimizing data, not just the models. That feels counterintuitive, doesn't it? Many think the cutting-edge algorithm or the massive computing power is everything. What's the core idea here? Why data optimization first?
Yeah, this is where it gets really interesting and maybe challenges some conventional wisdom. You're right. Many people, many organizations focus intensely on the AI algorithms themselves, believing a complex model will magically overcome data shortcomings.
Right, pour money into the model tech.
Exactly. They invest heavily in advanced platforms, hire top data scientists, but the manual and, frankly, real-world experience makes it abundantly clear. The raw material, the data, is paramount. The source emphasizes data is the focus for AI. And that interrelationship we discussed, figure 3.10, it pulls the model towards successful AI operation through the data. Data optimization isn't just making data better, it's about making it accurate, reliable, accessible, and perfectly suited for both analysis and decision-making by the AI.
Perfectly suited, like custom fuel for its specific engine.
That's a great analogy. Making sure your AI has the best possible fuel prepared just for it. Imagine trying to bake a gourmet cake with rotten ingredients, or fuel a Formula One car with low-grade gas. No matter how skilled the chef or advanced the engine, the result will be, well, inedible or severely underperforming. Data optimization is getting those ingredients precisely right.
That analogy makes perfect sense. So, if data optimization is getting the ingredients right, what does that process actually look like? How do we optimize data in practice?
Well, the manual describes it as a multi-step process. It usually involves data cleaning, enrichment, and transformation. And these aren't one-time tasks, by the way. They're often iterative processes, especially as data sources change or models get retrained.
So, iterative, what's first? Cleaning.
First, data cleaning. This is the foundational step. Identifying and correcting errors, inconsistencies. Removing duplicates or irrelevant information. Think of it like weeding a garden, meticulously removing what hinders healthy growth and clarity for the AI.
Weeding.
Yeah.
What kind of weeds are we talking about?
Things like correcting misspellings and typos, crucial for NLP models. Customer versus customer can mess things up. Standardizing formats, dates, addresses, units. And energy AI needs consistent units, kWh versus MWH, or predictions are useless. Handling missing values. This is huge. Do you remove records, impute them with averages, medians, or even ML techniques?
And the choice matters, right? Could introduce bias.
Absolutely. Especially for something like loan decisions, missing income data, if handled poorly, could lead to unfair denials. Then there's outlier detection. Are they real anomalies or errors? An AI might overreact to a single bad sensor reading if outliers aren't handled. And deduplication. Removing duplicate customer records avoids inflating counts, distorting personalization. The manual mentions this specifically.
And how would an auditor check this cleaning process?
Auditors would look at the methodology, the rules applied, check error logs, do sampling to verify cleaning didn't, introduce new issues or discard valuable data carelessly.
Okay, cleaning is step one. Then enrichment.
Second, data enrichment. This is about enhancing your existing data, adding more context, integrating it with other relevant sources, making it richer, more comprehensive. This could involve internal data integration, combining customer logs with purchase history, maybe website behavior. For churn prediction, adding support interaction data could reveal subtle patterns.
Bringing different internal pieces together.
Right, or external data augmentation, adding public data like weather patterns, economic indicators, geographic info, social media sentiment even, if relevant and compliant. Think crop yield AI enriching satellite images with local weather data. Dramatically improves accuracy.
Makes sense.
And a crucial part of enrichment for AI is feature engineering, creating new features, new variables from existing raw data to boost model performance. Like from a raw date, you might derive day of the week, month, this weekend, days since last purchase. These can be highly predictive.
Know what auditors check here? Source authority. Bias.
Exactly. Are data sources authoritative? Properly licensed? Does added data introduce new biases or privacy risks? If external demographic data is incomplete for certain groups, it could worsen existing AI bias.
Okay, cleaned, enriched. What's the third step? Transformation.
Third, data transformation. This is changing the format or structure to make it suitable for the specific AI model. Raw data rarely works as is. AI often needs numbers or specific structures. This could mean normalization and standardization, scaling numerical features to a consistent range, income, thousands to millions versus Age, smaller range, needs normalizing so income doesn't dominate unfairly.
So one feature doesn't overpower others just because its numbers are bigger.
Precisely. It also includes one-hot encoding converting categories like red, green, blue into numbers AI understands, and text vectorization, turning raw text into numerical representations, using techniques like TF-IDF or more advanced word embeddings like word-to-vec or
BERT embeddings, those capture meaning.
They do. They represent words as vectors in space, where distance and direction capture semantic meaning. It lets AI understand context and nuance far beyond keywords. An auditor might check if the embedding process accidentally amplifies biases from the training text, like associating certain jobs with certain genders based on the source text.
That's subtle.
Very. Transformation also includes aggregation, summarizing data like daily sales from individual transactions, and dimensionality reduction like PCA, reducing features while keeping key info. Vital for high-dimensional data, makes models more efficient, sometimes better.
And auditors review the logic here. Ensure nothing's lost or distorted.
Yes, review logic, code, configurations, ensure integrity is maintained, no unintended data loss, and transformations don't create artifacts leading to biased or wrong AI outputs.
That's a really comprehensive overview of the sheer effort involved. So given all this meticulous work cleaning, enriching, transforming, what's the ultimate goal? Why go through all this ongoing effort?
The ultimate goal is profoundly strategic. It's about orchestrating data so it truly becomes an organizational asset, a source of competitive advantage, enabling AI systems to operate successfully, ethically, and compliantly. It's about moving from reactive problem-solving, fixing data issues after they happen, to proactive data stewardship.
Stewardship, yeah.
By continuously optimizing data, organizations ensure their AI gets high-quality, relevant, well-structured info, which leads to more reliable, fair, impactful AI outputs. This isn't just efficiency, it's building trust in AI, reducing operational risk, maximizing ROI. For an auditor, it means verifying these processes exist, are effective, documented, and regularly reviewed for improvement, especially since data and AI models are so dynamic. #3 Data Science, Section 3.14.
Right. Once we've meticulously optimized our data, the next logical step in this journey, and a major focus of the manual, is data science. Section 3.14. The manual defines it as a multidisciplinary field. For someone who maybe gets AI concepts but is newer to data science specifics, how would you describe it? And its connection to AI and, of course, the auditor's work.
Right. Data science, at its heart, is about extracting meaningful knowledge, patterns, actionable insights from, often, vast and complex data. It's a powerful blend. Scientific methods, advanced processes, sophisticated algorithms, robust systems. Essentially, it's the art and science of turning raw, undifferentiated data into intelligent, actionable information.
Art and science, okay.
It draws on diverse fields: statistics for rigor, computer science for algorithms, and crucial domain expertise to understand the context, the specific problems. In the AI context, it's intrinsically linked because data scientists are often the architects. They design, build, train the very models learning from the data. They define problems, prep data, develop ML models, interpret results AI systems rely on.
So AI is often the application of data science efforts.
Often, yes. It's where the insights derived by data science get put into action.
That's a helpful distinction. It's not just running algorithms, it's that whole scientific discovery process. So what kind of concrete applications does data science support? Things our listeners might already recognize as AI.
Oh, an incredibly wide range, transforming nearly every sector. The manual highlights several key categories: predictive analytics, forecasting future outcomes from historical data. Think AI predicting next quarter's sales, which equipment might fail, credit risk, patient readmission rates, allows proactive planning.
Looking ahead.
Prescriptive analytics goes a step further, doesn't just predict what will happen, but suggests actions to optimize outcomes, like an AI recommending the best patient treatment plan based on genetics, or optimizing supply chain routes in real time, or dynamic pricing in retail, guiding decisions toward goals.
Telling you what to do.
Exactly. Then, classification tasks. Categorizing data into predefined classes. Common examples: spam filters, fraud detection, identifying objects and images for self-driving cars, classifying customer feedback as positive, negative, neutral. And clustering, grouping similar data points without prior knowledge of the groups. No predefined labels, like grouping similar customers for marketing, finding segments in gene data, detecting communities in social networks. These applications are fundamentally reshaping how businesses operate, innovate, make decisions.
That's a clear picture of the breadth. Now, bringing it back to our core topic, how does this understanding of data science apply directly to an AI audit? What's the auditor's role here, given all this complexity?
Well, for AI auditors, understanding data science is absolutely crucial. It's the lens they need to truly assess the model's internal workings, to identify potential issues beyond just input-output, and validate performance and integrity. It's not enough just to see the model's output. Auditors need to understand the methodologies used, the assumptions built in, the choices made during development.
Getting under the hood.
Precisely. Auditors might use their data science knowledge to analyze why a model made a decision that's interpretability, or whether it's showing unwanted bias fairness, or if the model's complexity is even justified. They can scrutinize the engineered features, model architecture, training process, assumptions. This deep understanding lets them effectively evaluate AI risk, confirm reliability, fairness, compliance, and provide credible assurance. Without this knowledge, an audit stays superficial.
The manual specifically mentions sentiment analysis as a prime example here. Can you walk us through that, maybe highlight the different approaches and what an auditor would be looking for?
Sentiment analysis. Yes, it's a perfect illustration. Highlights different approaches and complexities auditors face. It's the computational process of figuring out the emotional tone or opinion in text, positive, negative, neutral. Incredibly valuable for analyzing customer feedback, social media, reviews, surveys.
Okay, so how does it work?
Well, the manual explains two main types. First, rule-based sentiment analysis. This is simpler. Relies on predefined lists, lexicons, of positive and negative words. It might count good, great as positive, bad, awful as negative. Maybe incorporate rules for negation like not good. It's straightforward, interpretable, but less nuanced. Struggles with sarcasm, oh great, another outage. Or context sick, meaning illness versus cool slang.
Right, language is tricky.
Very. For an auditor, reviewing rule-based systems means checking lexicon completeness, accuracy, rule logic, ensuring updates for evolving language. Then there's machine learning, ML, sentiment analysis, much more sophisticated, much more common now. Uses algorithms like linear regression, naive Bayes, SVMs, even deep learning models. These models are trained on large data sets of text already labeled with sentiment by humans.
Learning from examples.
Exactly. They learn complex patterns, context, subtle cues, word associations indicating sentiment far beyond keywords. An ML model can learn that sick is positive sometimes, or maybe interpret sarcasm. It's much more accurate and subtle.
So what does an auditor check for these ML systems? It sounds way more complex.
It is. It's a multi-layered task they'd meticulously check. Training data quality and representativeness. Is a training data balanced across sentiments? Representative of the actual language and demographics it'll analyze. If it's trained mostly on text from one group, it might misinterpret others or perpetuate biases already in the language, like struggling with slang if trained only on formal English.
Bias in the training data is a huge risk.
Absolutely. They'd also check feature engineering. How was text turned into numbers? Were embeddings used? Were transformations appropriate? Did they introduce bias? Model selection and training. Was the right algorithm chosen? Were parameters optimized? How was it validated? Cross-validation. Model performance metrics. Beyond just accuracy. Look at precision, recall, F1's score for each sentiment class, maybe fairness metrics if decisions are critical, and interpretability. Can we understand why the model assigned a sentiment? Tools showing influential words are invaluable for debugging and trust.
So digging deep into the whole pipeline.
Exactly. To ensure the sentiment model is accurate, fair, robust, and transparent. Hashtag tag PAVV, data reporting, section 3.15.
Okay, once we've rigorously optimized our data, applied these powerful data science techniques, the next step in the manual's journey is data reporting, section 3.15. What's a fundamental purpose here, especially in the AI audit landscape? It sounds like translating all that complex technical stuff into something, well, usable.
Exactly right. Data reporting is that vital bridge. It collects, summarizes, communicates the insights from AI and data analytics, its primary purpose. To provide improved, data-driven decision-making. Think about it. Even the most profound AI insights involving thousands of variables, complex correlations, they stay locked away technically unless they're reported effectively.
Lost in translation otherwise.
Precisely. Data reporting makes these complex outputs understandable, actionable for diverse stakeholders. Executives, managers, risk committees, other auditors. Without effective reporting, AI's value is significantly diminished. Its intelligence can't inform human decisions.
So given that complexity, how is this information typically presented? To make it digestible for such a wide range of people, raw data clearly won't work.
You're absolutely right. The manual notes effective reporting often involves graphical summarization. Patterns, trends, data visualizations, moving far beyond raw numbers or code to easily digestible charts, graphs, heat maps, visuals. Visualizations are incredibly powerful. They let decision makers quickly grasp complexity, spot trends, anomalies, relationships invisible in raw data.
Seeing is believing, or at least understanding.
Definitely. Instead of a table of hundreds of bias metrics, a clear bar chart showing performance disparity across demographics immediately highlights an issue. Or a confusion matrix visually summarizes a classification model's performance correct versus incorrect predictions per class. Gives a quick overview of where it excels, where it falters. An ROC curve shows the trade-off between true positives and false positives critical for fraud detection or medical diagnosis models.
That makes sense. What are some common tools used for this? Tools auditors or AI pros might encounter or use themselves?
You'd find a whole range, from powerful programming languages favored by data scientists to dedicated BI platforms used across the enterprise. RStudio and Python, for instance. Powerful languages, extensive open source libraries for advanced analysis and visualization. Python has Matplotlib, Seaborn, Plotly for visuals, Pandas for manipulation. R has ggplot2 for statistical graphics. Data scientists love their flexibility.
Tools for the specialists.
Right. Auditors with coding skills might use these for custom analyses or validation. Then, more business-friendly options for a broader audience. Microsoft Excel for simpler reports, basic visuals, foundational but limited with big data or complex AI.
Everyone knows Excel, but yeah, it has limits.
Then you have the dedicated business intelligence BI platforms for robust interactive dashboards and advanced analytics. The source specifically mentions leaders like Microsoft Power BI, often tied to Azure, Tableau, and Clisense. These are built for enterprise scale. Connect to diverse data sources, process large volumes, present info via highly interactive dashboards. Users can drill down, filter, personalize views, invaluable for translating complex AI performance, audit findings, compliance metrics into clear, actionable reports.
So auditors use these BI tools too.
Frequently, to create custom views of AI system performance, track compliance, monitor control effectiveness against risks like bias or drift. They empower decision makers and support continuous monitoring. #V reports, section 3.15.1.
Diving deeper into those outputs, let's talk about reports specifically. Section 3.15.1. What do these reports typically yield in an AI audit context? What's their tangible value beyond just showing data?
The reports themselves, they're absolutely crucial because they are the formal communication vehicles. They yield specific insights into defects, findings, process failures related to AI systems throughout their life cycle. They are the tangible output helping organizations spot where things go wrong, where a model underperforms, where improvements are needed from data collection to retirement.
Not just summaries, but documented findings.
Exactly. They structure observations, highlight non-compliance, articulate specific recommendations for fixing things. They move observations into action. The manual states these outputs can be formal, static reports or more dynamic dashboards. For example, Figure 3.12 shows a continuous audit report, a fantastic illustration of how reports can go beyond a one-time snapshot. This report visually tracks key risk metrics. Risks by business area, showing which departments carry most AI risk. It highlights top 10 risks, prioritizing attention, and crucially shows risk exposure trend over time is overall AI risk improving, worsening, stable.
Continuous monitoring, not just point in time.
Precisely. A significant departure from traditional audits. Instead of just auditing after the fact, it allows proactive identification and mitigation as risks emerge. Vital for agile AI operations where models constantly learn and adapt. For an auditor, this visibility helps shift from reactive to proactive, risk-based AI governance.
So these reports are really a communication bridge, taking complex AI performance data and distilling it into something actionable for both tech teams and decision makers. Sounds critical for governance.
Absolutely critical. They enable organizations to move from observation to informed action and robust governance. For an auditor, a well-structured report presents findings with context, clear evidence, linking back to data or model behavior, and explicit recommendations. This ensures accountability for AI performance, facilitates understanding of risks, bias, data issues, compliance gaps like GDPR, security vulnerabilities. These reports become the basis for management responses, remediation plans, ongoing oversight, ensuring AI is operated responsibly, ethically. They're the artifacts demonstrating due diligence. #C. Dashboards, section 3.15.2.
Okay, finally, let's turn our attention to dashboards. Section 3.15.2. You mentioned it briefly. How do they fundamentally differ from those more traditional, often static reports? And what unique, maybe more immediate role do they play in AI audit and operations?
Right, dashboards. They are indeed powerful visual tools, as the manual describes, but they're uniquely designed for real-time or near real-time insights, intended to dynamically inform processes, accelerate decisions, facilitate partnerships. While traditional reports might be static, historical snapshots like a quarterly financial statement dashboards are typically dynamic and interactive.
Live and interactive.
Exactly, offering an at-a-glance yet deep-dive capable view of key metrics. Users can continuously monitor performance, spot trends unfolding, drill down as needed. This dynamic nature is particularly valuable for AI systems, which are often continuously learning, evolving, processing new data. An AI model's performance can degrade due to data drift or concept drift. A dynamic dashboard is ideal for detecting that degradation instantly.
Like the car dashboard analogy again.
Precisely. They consist of aggregated data analysis and visualization output in a centralized, intuitive, easy-to-understand format. At a glance, you get critical, real-time info. An AI audit dashboard gives a similar overview for its domain, showing real-time model accuracy, fairness metrics across groups, model retraining rates, compliance status. Such a dashboard could instantly alert stakeholders to a sudden accuracy drop, a spike in bias, a deviation from expected thresholds, allowing rapid intervention, proactive risk mitigation. It's an operational control itself.
And how are these dashboards delivered or consumed? Is it just a screen display for a few people or more integrated?
Oh, they're incredibly versatile. Designed for broad accessibility and integration, primarily displayed via a web interface, making them easily accessible across departments, even to external partners, with proper controls, of course, democratizes insights.
Browser-based easy access.
They can also be exported as static files, PDFs, images for sharing or archiving, though losing interactivity. But here's the crucial part the manual highlights. They can also be programmatically consumed by other systems or offer specific reporting mechanisms. This allows deep customization, seamless integration into workflows.
Integration, like triggering alerts.
Exactly. If a model's bias metric on the dashboard exceeds a threshold, it could automatically trigger an alert to the ethics committee, maybe initiate automated retraining, or even pause the model pending human review. This level of automation and integration transforms dashboards from just reporting tools into active components of AI governance and operational control.
The source also provides an example, Figure 3.13, a data dashboard. What does that specific example show us? How might an AI auditor use something like that day to day?
Yes, Figure 3.13. It's very illustrative of a typical risk management dashboard, perfectly applicable to AI audit. It usually displays key metrics and trends visually consolidated. Typically shows risk movement is overall AI risk increasing, decreasing, stable. Breaks down risk exposure category, classifying risk by type, bias, drift, security, compliance, or by business area impacted. Includes risk exposure trend over time, showing the risk trajectory for forward-looking management. Might also include top 10 risks by category to prioritize attention, or a heat map combining likelihood and impact to quickly spot critical high-risk areas.
So how does an auditor leverage this?
For an AI auditor, such a dashboard is invaluable for continuous assurance and targeted auditing. They could use it to monitor model performance, track accuracy, precision, recall over time, identify degradation indicating drift, flag audits if thresholds are breached, assess fairness and bias, continuously monitor fairness metrics across groups, track if a lone model shows disproportionate denial rates for protected groups, allowing immediate investigation.
Catching bias in near real time.
Exactly. Track compliance. Monitor adherence to regulations like GDPR, explainability rules, or internal policies. Oversee explainability. For black box models, track how often outputs are explainable versus opaque. Identify emerging risks. Use the trend view to see if new risks pop up or existing ones escalate. Resource allocation. Use the top 10 risks to help the audit team prioritize efforts.
So it provides this transparent, efficient, proactive overview.
Right. Enabling continuous assurance, not just periodic reviews, which, raises an important question itself. In this world of ever-increasing data and AI complexity, how can we best design these dashboards? Ensure the right insights reach the right people at the right time, preventing information overload while still providing comprehensive, actionable oversight for managing AI risk. That's a key design challenge. Hashtag tag tag outro.
Well, that was a truly insightful, really in-depth exploration into data quality and analytics within AI auditing. We've seen how everything from the fundamental excellence of data, making sure it's accurate, complete, consistent, relevant, all the way through meticulous optimization, cleaning, enrichment, transformation, and then it's detailed reporting via dynamic dashboards.
Wow.
How all of that is absolutely critical critical for the trustworthiness, effectiveness, and, frankly, the responsible operation of AI systems. It really is a journey from raw input to actionable intelligence.
Indeed. And understanding these concepts, it isn't just, an academic exercise. It's about ensuring AI systems are not only efficient and powerful, but
Hmm.
also fair, transparent, accountable, and ultimately reliable. It's about taking raw information, which can be messy, incomplete, even misleading, and transforming it into reliable, auditable intelligence that supports sound, justifiable decisions. The auditor's rigorous role in verifying these data processes from ingestion to output is absolutely paramount to building and maintaining trust in AI. It really is the foundation of confidence.
So what does this all mean for you, our curious listener? As you engage with AI systems in your own professional life, maybe as a user or developer, maybe preparing for an AI audit. Consider this. The quality of the data isn't just some technical detail to be, outsourced or overlooked. It is a fundamental operational, ethical, and strategic concern. Poor data can lead to skewed decisions, perpetuate systemic biases, erode public trust, and ultimately undermine the very purpose of AI, potentially causing significant financial, reputational, or even societal harm. It's that invisible foundation, and its integrity dictates the AI's integrity.
And this raises, I think, a crucial question for you to mull over in your own field. How might a deeper understanding and more active, continuous management of data quality and analytics transform the insights you gain from AI? And what hidden risks, or maybe even opportunities, might you uncover by looking closer at the data itself rather than just accepting the model's outputs at face value? Think about how ensuring data excellence could fundamentally shift your approach to AI implementation, governance, and its overall strategic impact in your own organization.
That's a powerful and practical thought to leave with. Thank you so much for joining us on this deep dive into the foundational world of AI audit data. We hope you feel better informed, more curious, and ready to explore these concepts further in your own contexts. Until next time, keep digging for those insights.